So this is what I did. I asked it to read this computer and then read this agent. And so using the MCP tools that I've given it, it figured out that down the bottom here, the computer is called Universal Compute, which is the equivalent of the Fly app. And the agent is itself is this. This is the DNS name of the agent. It was auto-generated by Fly. I didn't get to set it, but basically it understands the language of agents and computers. There are these servers that I've set up, these MCP servers. So there's a computers server, which is used by anyone with enough privilege to create computer, destroy computer, list computers, read computer. There's an MCP server for managing the life cycle of agents, which is create agent, destroy agent, list agent, read agent. There's an MCP server for interacting with faces. Those functions aren't present, but they're going to be, I think they're all the same pattern. It's like create face, destroy face, list faces, read face. And then the last one is a new term I introduced called interactions. Again, the same create, destroy, list, read. And my hope or my theory is that I haven't actually overfitted with that pattern, and that the repetition will in some way make it easier for the bots to understand how the entities and relationships all fit in together. I hope.
You should. Yeah.
So there's a bit of like prompting and a bit of like, who's doing what and all that.
There's no right. Curiously.
You mean no update?
Yeah.
Update is the principle I've gone with is there is no update. You just delete it and create it. And so those are a couple of the design decisions that I made that I want to check through with you to make sure that it's not doing something weird. So one of them is that when you create an agent, at creation point is when you lay down the sysprompt, what Git repos it's going to be working on, basically its configuration, and then it stays set. And if you want to change it, you need to delete the agent and make a new agent.
Okay. All right.
Now, does that sound okay?
What would you be losing if you wanted to make a small tweak?
Well, I'll tell you what you're gaining. You're gaining not having to teach the bots about when to choose to modify something or not. You're gaining not having two independent agents interacting with another agent, and then one reprograms the agent with different sysprompt while the other one's mid using it. So you skip that.
So, kind of race condition equivalent.
You in the race conditions. It's like it's significantly simpler if you once you've got something, you're like it stays set. It stays there. You don't have to ever even think about it might have changed. If you want to change it, which I don't even know why you would once it was set up, but if you did, you should make a new one.
So there's like single shot, and presumably they're all pulling from a common store. So if you want to make a tweak, and you got a running agent, it's like store your
you should
stuff.
Well, you mean like if you want to modify the sysprompt of an agent to improve the performance of the agent, is that what you're talking about? So in that use case, I believe your best mode is to have one agent that's set up specifically with the goal of improving this other agent image. And so what it would do is it would make a load of tweaks, and then it would fire up disposable agents, all with slight variations on their sysprompt, and it would exercise each one against a a set of test cases to check whether the behavior improved or not. And once it had settled on one that it liked, it would, after cleaning up its mess and deleting all of them, it would then update the agent image.
Okay.
Isn't that the best way to do it?
Yeah, it's possibly. So if I loaded up an agent and I was happy with the conversation and I was unhappy about the sysprompt, I don't want to have to re-upload the previous part of the thread. It's like, that's just a nose. I want to be able to.
So you want to break off from a thread and then carry on with
Yeah.
a modified agent.
And agents are discontinuous. Which
Yeah.
is fine.
So what's appearing as one of the critical features of the system is that at each point when the model or the LLM has returned, you should be optionally able to checkpoint the system. And at checkpoint, that means that you can carry on the conversation with a different agent.
Yeah, precisely. Exactly that. And I don't care. I mean, agents are discontinuous, and so I don't care if it's actually.
Yeah. So, but there's another way you could approach that, which is to say that I'd like to transfer this whole conversation to another agent. And then you would move the whole thing over, the whole message history, you'd move it over to the new agent with the modified sysprompt.
Right. But the reason I usually come across is having to pistol whip an agent. So the sysprompt is X, and I ask it Y, and I go, no, that's not what I meant. And then it comes back with, oh, do you mean this? And it's like, no.
I think in that case, you're better to go into the stuck system, which its rudimentary form is just an agent that is prompted to help you work through improving a given situation. And so
yep, absolutely.
And then so you'd end up with an improved agent, and then you'd restart that new improved agent after, let's say 20 iterations of self-fixing and self-reflection, and then you'd resume the new modified agent from the point in the conversation before it all went hairy with the response that you wanted, which is how the improvement system knew that it had done enough of its job.
Yes, and you can collapse out what you're passing over to the new sysprompt.
Oh, you can rewrite the whole thing if you wanted, no problem.
You can remove all the whole pistol whipping, because the pistol whipping is actually now encapsulating into a changed sysprompt.
It's handled in the sysprompt, yeah. And so there's another sort of a long-term principle or gamble that we're talking about there, which is to say that in the future, pistol whipping's all you'll need. You won't need fine-tuning, because pistol whipping will give you enough of the results you want, I think. Is that a fair bet to say?
Yes, I've never resorted to fine-tuning yet. Fine-tuning is
right, but you've also, to be fair, you've never really hit really hard, gnarly problems.
That's true. That's true. It's all been NL.
It's all been synthetic as well. So, but I think, yeah, would you agree that that's the trend, though? That fine-tuning is becoming less useful?
Yes.
No? Yeah?
Yeah, I would.
Yeah. Because GPT-5 seems really good at following its instructions.
But also, OpenAI and the others are behemoths that are kind of dealing with fine-tuning behind the scenes.
Yeah, that's all they're doing, right? They're they are the fine-tuners.
And if you try and compete in that space, good luck.
Yeah. Okay, so so it sounds like I genuinely think the problem you're talking about there is not solved by modifying the sysprompt of the agent you're on. It's best solved by modifying the image of the agent repeatedly, preferably without your input, really, and then continuing the conversation with a new, improved agent.
On the fly.
Yeah.
Yeah. I don't know what the marginal improvement would be on pistol whipping. Pistol whipping is pretty good.
Yeah, but it's if you have to do it, it couldn't possibly be the best because you can't.
Yeah.
All
Yeah,
you're
that's true.
doing is you're just programming, and
Yeah,
when you
that's
program,
true.
you can't consider like more than a handful of other situations you also wanted to satisfy, and so you need machinery to come in and make sure it still holds correct across the diverse range of use cases that you're aiming for. Plus, you can guarantee that the bot can do a sysprompt better than you probably.
Well, importantly, also, habitually, I found myself only reporting by exception, and pistol whipping is always negative. It's like, no, I didn't want to
Yeah,
do that.
yeah, yeah.
As
That's right.
opposed
That's
to,
right. That's right.
could you try and do that better?
Right. And you also don't have enough time to experiment with like deprompting it and then building the prompt back up with positive reinforcement. Not to sound too airy fairy there, or calling in an MCP system to make it more obvious what you want to do, perhaps.
Right.
Yeah.
Yeah. Yep.
All right. So it sounds like maybe there's a couple of wrinkles there that you're like, we'll see how we go there. But from what you've said, if that's all you've got in terms of what you might lose, which might not even, I think that's a gain for you, that new system, but I might be wrong. But if that's all, like the ills that are reduced by that immutability are many. So,
Okay, good. Well, yeah.
so I like if there's a little bit of a wrinkle, I'm sorry, but I promise you, if I gave you the mutable form, you would strangle yourself much quicker.
Yeah. Yeah. I see.
All right. So the way I've laid it out is here's how the relationships work, I think. There's a computer which is made of a collection of agents. A computer contains one or more agents.
Yep.
Every agent belongs to exactly one computer.
Yep.
Every agent has at least one face.
Yeah, because otherwise, what are you going to do with it? Yeah.
What are you going to talk to, right? Every face has 0 or more views.
And by views, what's the definition of a view?
A view is a way to look at the face. And so, like, a simple distinction would be reading versus writing. I might present a read-only face to some people, a read-only view to some people, and other people have a writable.
Oh, you said 0 or more. What would a 0 view look like?
Just logic running in the background. It's not.
Is that not a type of view? Or
No, because that seems like the face. Because the last thing I wanted to add, and then we can come back to this debate here, is the interaction. And the interaction is the word I chose to mean a message or a command, or it's an event that you sent in that you're expecting some kind of state change within the agent to occur.
that makes sense. I mean, again, it's difficult to figure out what you do with it without interaction.
Well, yeah, right. Another word I considered was command, but command doesn't really fit when you're just having a chat.
Yeah, you may not be asking it to do anything.
No. And so, because I needed this model to work for not LLMs as well. So, in an older way of thinking, a computer might be a cluster. An agent might be a server. Sorry, let me try again. A simpler old school version. A computer might be a hypervisor host.
Mm-hmm.
An agent might be a VM.
Mm-hmm.
A face might be an SSH session. And
Yeah.
a view would be, if you came in with an interactive terminal versus just sending in it.
Right. So a zero view would be a headless.
Well, yeah, it's got no shell, no interactive shell, so you can still send in commands and things to be edited, but that blinking cursor is a view. You're lucky to have one. It's not guaranteed that you'd.
Right. That makes sense.
That's what really all I was getting at there. Because if you treat the view separate to the face, it means that you are now able to have different ways of presenting a view of the same face.
What's the relationship between view and interaction? Because I could come
Nothing.
in with a shell and then interact with the face.
Right. But the view is just showing you what the state of the face is. That's all. The interaction is not. It's just, it may or may not be surfaced in the view.
Sure, but when I interact, I'm interacting with the face.
You're interacting with the face, yeah. You might be doing that from a view, but you're still.
Oh, I see what you've done. Yeah.
These are the things that are hard, right? Like
Yeah.
because if we get this thing wrong, we can fix it, of course, but I'm like, I worry that I overcomplicated it, but it does seem pretty minimal.
No, man, this is not complicated at all. This is golden.
Well,
it makes sense. Now, whether it's right or wrong, I don't know.
Right.
It's simple to understand, right?
Right. So the reason why you need a face and you don't just interact with the agent directly is because it seems like an agent represents a zone of mutability. It's like shared. It's a shared zone, or a consistent zone of mutability, like a single file system, like a single checked out Git repo.
I like your analogy. Is the VM, you can have as many people as you want interacting with that VM.
Yeah. Now, there's other ways you could have gone. Like, we could say that you can only have one face into one agent, and that's that. But
it doesn't seem that's useful.
It seems too simplistic. Like, when I use Codex, I often want to do concurrent tasks on the same file system, and having multiple faces allows me to do that because I can come at it doing different things. I'm interested in working on the same mutable thing. Just because it's mutable doesn't mean that I only want one view of it. I want several ways.
And also, if you're to have a one-to-one between agent and face, why not just combine them?
That's the point. Well, that was one of the options that I thought about, but then agent becomes quite restricted. Like when you use, so when I develop, right, I'm developing in a Docker container here, and I've always got several terminal shells open. This is one code base, and I always have multiple terminals open. I don't want independent.
Yeah, but it also seems like it obfuscates the fact that if you're to combine face and agent, there are going to be different threads unless you want to do one thing at one time, but all you're doing is hiding it inside of agent, which seems
it just sort of felt like like you needed that extra freedom was what it seemed like. All right, well, it sounds like you agree with that. It's just that it complicates it a bit, and I'll tell you why. Because when you want to just do a new job, like you want to ask what the weather is in Scotland,
Yeah.
and you want to do it via an agent, you have to go create new agent. Then you got to wait for that to finish. It's pretty quick. It's like under a second. Then you have to create a new face, because I don't know if we want to get into the realm of default faces, but
Well, you said there's one or many faces to agents, so it's always going to have to create that. So that's kind of wrapped up in the.
Yeah, but it's like if you don't make one explicitly, it would be like trying to use SSH to get into another computer, but you didn't want to start your own SSH session. You just wanted to jump on board with whichever one other processes on your computer had already started. So you kind of need your own one. Like you need a signal to the agent that you're like, hey, I'm starting a new topic. Like another way to think about a face is like a chat within ChatGPT. You're like, I'm starting a new chat. Otherwise, I'm going to inherit the chat status from wherever else. So,
Yeah.
it gets weird. It
semantically, it doesn't make sense to have an agent without one, at least one.
It always has one, but you shouldn't. It seems not useful to interact with that one face, other than getting like I would call that like the status or the stats or the root face or that's like the system log. That's like the face of BIOS, like it's under the hood. It's like runtime 0. It's the lowest system, right? And then when you come in with a face, which could be various things, like one example of a face is starting codecs. So the application codecs would be started as a face, which is equivalent to me going here. So this is an exact example of that whole process. Here, let me just so I'm somewhere and I want a new agent. So I go new shell, right? That's created an agent. And then I go, I want a new face. The face is going to be the codecs face. I bound it to the letter C.
Yep.
Now I've started a face with codecs. And now I have an interaction. And I hit enter, that's the interaction. The interaction goes in. So I did actually do all those steps. I created an agent. I created a face, which was codecs. I then created an interaction and pushed it into the face. And now I'm waiting for the interaction to complete.
Yep.
So, like these are the bits that feel clunky to me, right? I'm like, I can't figure out a way to not have the face there, but it does feel like a little bit laborsome to go new agent, new face, new interaction. But then if you've got them hanging around already, if you've already got an agent on hand and a face on hand, interaction's easy. If you've already got an agent, then making a new face and then interacting is easy. I guess it only feels a bit weird when you start for the first time.
And just so I'm clear, the view is effectively your screen on the previous screen.
So yeah, the view, yeah, exactly, because it doesn't have to be like this. So the view is like this is a view.
Right. So it's pushing information out.
Yeah. Interpreting it, presenting it, because the key to the system seems to be that we allow you, the human, to jump in at any point, whereas previously in all the other versions of Artifact, during the process of block making or that transient state in between, you're at a block and you're whirring away to make the next block, it was strictly considered human hands off, humans out. But this model is invertedly different in that the whole interaction of the system is within the transient block making state. That's all that there is.
If I were to create another face for an existing agent,
Yes.
from that new face, how much would consider what the previous face was doing? Or would
it would consider everything that was within the mutable domain within the agent. So if you had started the face, so here's an example of how that would work. I would make, this is the same age. Oh, what did I do? What did I do? Christ almighty. How? Oh, yeah. Okay. Here we go. So now I'm on the same agent because under the hood, this is the same mutable file system. I have the whole thing. Everything's the same. The mutable domain. Then I start up a second face. I'm going to use a file explorer. Now the view presented to me is the file explorer, and each arrow press is an interaction that I'm sending in to the agent. Both these faces are operating on the same mutable zone. They're in the same blast radius. They can affect the files of each other. I could configure them to not do that, but they are within the same RAM. They're within the same permission space in a way. They're the same processes. They share the same ultimate root of their process tree.
That makes sense.
Yeah.
Okay.
Yeah. It's been quite hard, man. Like this is the result of a lot of didn't look like of not this. But I think that this is enough to build with. So yeah, and the other paradigm that I need to check with you is the paradigm of how we will manage asynchronous tasks being run by agents. And so my idea is actually GPT-5 Pro gave me this answer. I feel like because I paid the bills for it, it belongs to me, this answer, but it feels weird. It almost feels like I stole from the bot. It wasn't actually my idea. The bot suggested it, and I was like, that's a great idea. I'm going to take that.
Yeah,
but
you could get over that, yeah.
Be that as it may, the way to do these function calls is to first you go create interaction, and then that gives you back a interaction ID. And then the second call you make at your leisure is await interaction, which means that as this particular instance of Codex that you see on screen, or not, I'll give you like a size bump there. In this particular instance of Codex, it would be able to come up with a bunch of tasks that it wanted to do, fire them all off, possibly in parallel, and then go and do some more stuff. And then when it was ready to receive the results, it would call await interaction, which would block until that interaction had completed. And that's the model. That's the...
Sounds like a promise, sort of.
Well, you start it and you get a promise, which is the ID. And then when you decide that you've done everything else you can, then you decide you need to wait for the promise. And you can set things like timeouts, like I only want to wait 2 minutes or whatever. To leverage one of your questions earlier about having the two different faces looking at the same thing, having the faces like this allows you to have one face churning away on a long running question, and then a second face come in and you're like, how's that guy going? How's interaction number 54321 doing? And it can read the disk and check the status of the operations that this other thing is doing and tell you without interrupting the primary operation.
Or ask it some really pointy questions like, should we kill this guy?
Right. Like, I'm thinking of killing him. Give me some plead for his life. Tell me why he's doing a good job. I think he's run off piece, blah, blah, blah. And so you can multiple faces is an amazing amount of power for only a little bit of extra complexity. Like, that's kind of how I've been approaching this design, is like, if it's a little bit of extra complexity, it needs to deliver a hell of a lot more power. And I think that all of these things do that. Like that addition of allowing more than one face, like that one symbol there, gives you that sideband checkup.
So how does one agent interact with another agent? Where's the entry point?
Through interactions.
So it discovers another agent saying, hey, you can do this for me.
Yeah.
Here is an interaction. I'm sending that to what, a face or an agent?
So it fires up an agent, and then it fires up a face. It may just be a new instance of the default face, or it may be that the agent can support multiple face kinds. So an example of a face kind would be Codex would be one kind of face. The bash terminal would be another kind of face. These different faces are chosen by the caller based on what the agent can support. And then the interaction is, again, got a should have in here an interaction kind. So at this stage in software development, interaction kind is going to be text, structured JSON, images, or audio, because that's all that the models know how to handle. But it really could be any kind of internet multimedia type, like any MIME type could be sent in as an interaction.
Is there an always publicly available surface of a face that anyone can ask an interaction of?
Not unless it's configured that way, but that is the critical design pattern for our gateway system, which means that you come to Dreamcatcher.ai and you land on the default agent, and you land with a brand new face using the default face, and you are free to submit an interaction from that point. And so you're effectively, openly, publicly talking to our gateway agent that we set up to take on any queries from the internet.
Right. And there's two obvious ways of doing that. You could ask the agent to spin you up your own private gateway, or you could go into a public gateway that is already existing.
Yeah, and so that's how we onboard customers. Like, you turn up to our public gateway, we chat you up a bit and tell you a funny joke, and then convince you to sign up. And when you sign up, we make you your own computer. When we make you your own computer, we provision a default gateway agent for your computer. to access your computer, you have to have passed authentication. So it's really only for you or anyone who can masquerade as you. But when you land with no other information, you land on the gateway agent. It's like, hey, how's it going? What's up? And it will help you do other things or learn the state of the system from there by drawing on other agents.
Yeah, but you don't land on an agent.
You always land on an
face.
agent. Oh, sorry. You always, yeah. You land on a face, but it's, yeah, like every face has exactly one agent. But
Yeah. But that's your window into the agent.
yeah, a faced agent. You land with a nicely,
Yeah.
a well-faced agent.
There's something about view and interaction that seems to be there is some correlation there. That a view require, does a view require interaction?
No, it does not. Interactions are actually optional.
Does an interaction require a view?
Nope. A face interactions are entirely optional. You don't have to have them. Views are entirely optional. You don't have to have them.
Right. So your primary interface, pun,
maybe that's actually where the root of the word interface comes from. Is like the face of the system.
Yeah.
Is that stupid to think that?
No, I don't think it is, because what we're talking about is with more than one agent, all the work is being done between faces, interface.
Interactions between faces. And so I guess another way I could have drawn this, if I drew interagent communication, is that there would be, the interactions would be two-way, going back and forth, and you got another face over here and another agent over here.
Yeah.
Right?
Yeah.
So my worry is that is this system able to do all of the structures that we imagine? And I find it hard because haven't even really got one going. I've sort of got a crude, sort of crummy way of doing it, but that's really my issue. And it sort of looks like I'm like, well, I'm not seeing a blockchain here, I guess. I can go into that more, but I don't think it matters for getting us off the ground. Let me just show you what it can do, though. So if I say, create me a new computer named Smacks. So this is me building your computer, using my computer, interacting with my agent through the face and interpreting it via the view.
That's kind of cool. Where does it live after it's created?
I'll show you. New computer. Oh, you got a nice ID. You got the ID P7. Okay. So you got a computer named Computer User Smacks.
Yeah.
Your first agent is named Agent Zero.
Boom. Yep.
It's in Sydney because I'm in Sydney. It should really be in London, but don't begrudge me for that.
Doesn't know where I am anyway.
No. Who does? And where does it live? Well, here is the fly org that was made in. This is your computer. It's its own dedicated app.
Look at that.
That's the dedicated app named Smacks. And now the machines, where one machine equals one agent, this is your agent. It's called Agent Zero. And it fired up. It's got an IP address, blah, blah, blah. It's got all this stuff. And that's it. That's you.
So now I've got. Where's my face?
Well, you would ask that. Fair enough too. You don't have one yet because I haven't done that bit. Because that bit, I well,
I was going to
um,
say that. Is that when
I,
you? No, you're not. No, you're
yeah,
talking to your
because
agent. I don't know.
yeah, I
Your
could
face.
SSH into it. But I don't know what that would prove. I could SSH into it because of my credentials. I'll do it just to, I don't know, prove a point or something.
No, it's not. I get what you're saying.
You know what I mean, right?
You're still in your zone of influence. You create a new computer,
Yep.
new agent, new
A new
face.
computer, a new agent within it. That agent naturally has a face. Because I mean it booted from the same image that this one is running right here.
Right,
So it is the
right.
same computer. It's just the dynamic stuff is slightly different, and that's where you'd boot with different sysprompt, different collections of MCP servers, different Git repos would be pulled down. That's the difference in that agent. And then from
Yeah.
that point on, you start interacting with it by having interactions just like I was here. And then it can also interact with other agents within the same computer. I haven't quite figured out how intercomputer communications work. I don't think it's terribly tricky. I mean, agent to
Yeah.
agent is the
You
tricky
just
bit.
took away my next question there. Yeah.
Yeah, so
Um,
computer to computer, I don't think is going to be a big problem. So and then you can make a lot of these things, right? Like I can go in and I can just for shits and giggles, I'll do it. Let me get the size up here. Okay. Now, if I go and fly SSH console dash dash app computer user smacks. So I'm SSHing into your agent.
yeah.
And I can prove that it's your agent by doing this. Oh, I didn't set your secret. My bad. Anyway, there's some rough
I
edges.
get where you're going with that.
Yeah,
I get
there's
where
some
you're
rough
going with
edges.
that.
Okay, so if
Yeah.
I get out of that, and then I go fly scale web equals 20. Oh, I didn't. Anyway, again, rough edges. This has been my life lately. Basically, like try some shit, hit some shit, be like, fuck, and then have to
I
fix
see
that.
where you're going with that one.
Yeah, and then you can basically like fang it out to be like, you want 20 agents, you got 20 agents. In fact, you can have a significant number of agents. If I go fly platform regions. Yeah, there we go. So if I go fly platform regions,
Mm-hmm.
this is the this is the current available number of agents that we could spin up in each of these areas right now. So if you add that all up, you're probably gonna get to if you really wanted, you could have maybe 10,000, no, maybe 5,000 before any alarms went off. So a
Ireland's
lot.
not there.
What?
That's interesting.
Who?
Ireland's not there. Ireland.
What your point? I mean, what?
No, I'm just curious. Ireland is actually the lowest latency from Scotland, not London.
would have thought Scotland was the lowest latency from Scotland, but that's
Oh,
not
yeah.
there either, is it? I mean,
No, there
um,
isn't one in Scotland.
yeah. So that's that, and kind of what I was thinking is that you could actually model every kind of process that I can think of could be modeled using agents of varying degrees. Like you take GitHub, where you've got GitHub Actions, and then they kick off a CI cycle, and then they publish a release, and they make a web page. Like GitHub Actions is just an agent. Like using this agent model of computing, you can replicate any of these fancy ass systems because it's just an agent that sits there, it is triggered by something, it does some predictable deterministic steps, and then it may call another agent or cause some other state change which triggers another agent. You can model any of these systems, and where we've ended up in the world is you got these horrifically intertwined systems that are all trying to be black boxed and fighting for their own territory, but really they all just come down to something that can be modeled in the agentic way. And a lot of them have code that's very complex because it makes decisions and deals with edge cases, when AI is very good at dealing with things that it hasn't seen before in a reasonable way. And so you could recreate a lot of these systems, like continuous integration pipelines, build pipelines. You could integrate them using agents and AI with much less code, but you've got this full visibility into the system, this full replayability, this simulation ability. You can, like, the number of times that I've got long strings of commits where I'm trying to fix the GitHub Actions setup, that shit takes hours. Whereas in this system, you're in there on the agent, you're interacting with the computer directly, you're not removed. And that's really my main gripe with cloud, is because you're always so removed from your machines. You gotta like look at some logs, do some weird sort of shit on the side. Whereas in this model, you're in there, you're one of them, you're one of the cloud computers. It makes the whole thing be like local net.
Yeah. Yeah. No, I see that. Mm-hmm.
And so again, like the other last call we had, you were asking about how can you could have a browser that was pointing at two different faces, and I was like, no, you shouldn't do that. And the reason is that if we can keep the browser as just this thick as shit, like just really dumb, simple thing, because having two views introduces client-side code. And I think that's actually the long-standing enemy, client-side code.
Mm-hmm.
And again, if you think about how MCP was designed, MCP is against client-side code because it allows you to connect to the server with a standard client that you'd use for any server and discover the capabilities of what the server can do on the fly. So it is with an SSH with a shell terminal. So it is with Telnet. Like as soon as you introduce client-side code, I think there lies the devil, and that's where things went astray.
Mm-hmm. Mm-hmm. Yeah, we talked about that 3 calls ago, and I think you're coming back with the fruits of that hypothesis.
I think so, but man, it feels weird. I'm like, fuck, we just axed. We just axed like literal mountains of code, and I'm like, what did we miss? What did we miss? What can't we do? What's missing? And I'm I guess feeling pretty empty because I'm not, first of all, not finding anything. So either I'm too stupid or, maybe it's not there. But if it isn't there, then I'm feeling depressed because of the amount of time in my life that I wasted because I was sucked into this client-side code trap.
Yeah, but that's running behind you. What use is that?
Well,
Sorry to be so cold about that. I probably should have warmed that up a bit.
that's
Uh, the point being, are these Lego blocks enough for what we want to do?
correct. That's really my question. Are they enough? And then there's a little bit of an extra question, which is, are they too much? Like, are they just the right amount? Is kind of the nervous question.
I've only got 6 minutes left, but the only question in my head is about inter-agent comms.
What's the question?
Which should be, I'm just forming it.
Oh, sorry.
Presumably between interactions. So there'll be
With via interactions. So the communication is actually between faces, and interactions are what the faces pass between each other. Where the
Correct.
response to the response to one interaction is the input interaction to the other.
Right. So the exposed surface of an agent is a face. There's always one. Another agent presumably can discover that face and say, "Hey, dude, can you do this for me?" That would be an interaction.
Mm-hmm.
So I'm still a bit fuzzy on that because what we got here makes sense, absolutely. But with an agent-to-agent interaction, the flow, I think, would go two agents already exist,
Yep.
and therefore implies that two computers already exist.
Yep.
Actually, they could be running on the same computer.
Correct.
The one agent wants to talk to another agent and ask
Correct.
it to
Yep.
offload some stuff.
Yep.
And so discovers its face and creates an interaction.
Yep.
With that agent. That interaction goes to Agent 1. Agent 1 does some work, works through the interaction to the face of Agent 2, who receives it and goes, "No, that's what I asked for, but was not what I meant," and goes back through a common interaction.
Yep.
Okay, all right, I get it. All right.
And so the way that you do it is if it's a brand new discussion or brand new job, brand new task, that means that you'd make a new face on the other the other agent, and then you'd send in a message, and then if you got back something and you're like, no, that's not quite what I meant, you could continue the existing one with another interaction, which is just like a multi-turn chat. Or you could start a new face to start from scratch.
Yeah, or you could turn down a face going, "Yeah, don't need that anymore."
Yeah, or bin it, or you can cancel it.
Yeah.
You can cancel it and destroy it. You can just cancel that interaction, or you can cancel the face, or you can cancel the whole agent if you're that mad.
So long and thanks for all the fish.
Yeah, or cancel the whole computer if it offended you. So
yeah. Okay, that does seem to hold water.
Right? Is it wrong to feel strange about that though? Because it seems like
I'm feeling a bit strange as well.
It's not a lot. Like, it's quite quaint. It's like, well, where's...
Well, the fact they can, you could like zoom out and put it all on one screen, and it's like, there's your architecture. It's like,
That's kind of my point. I'm like, that doesn't feel... That's really not... There's not a lot there, dude. That's my problem. There's no motive complexity. There's no, like, big mountain to climb, and it's like, this is so simple, so basic, that you couldn't really claim it, almost. It's like trivial.
yeah. But then, I mean, complexity is bad. More things to break. More weirdness. but simplicity seems like this is just the commons. Anyone could pick this up.
Yeah.
And,
Oh well. I mean, that's where we're at, I guess. So, I mean, that was reassuring to talk to you. It sounds like I haven't gone completely off the
no,
reservation there.
you haven't, but all you've done is manage to transfer your weird feeling to me
Good.
for that.
Good. Eat it.
Um,
Solve it. Overcome it. Do something with it.
Okay. All right. Right. I need to go.
Cool,
'cause
man.
I've got a hard stop. Shall we do tomorrow as well? Because I
That
think
would be
that's
great, mate. There's quite a bit
Mm.
more than this, but this is the main one.
Yeah.
All right, I'll see you tomorrow, buddy. Thank you.
Yeah. No worries. I'll see you there, man.
Okay, good luck.
See ya.